All right, for Algebra 2 today, we're going to cover 2.4, which is more about linear equations. We started linear equations with the last lesson, and we talked about like slope-intercept form, right? Which is y equals mx plus b, right? We talked about intercepts, didn't we?
Yeah.
Right? And some other stuff about lines. But today we're going to just learn more. Basically, it's just like continuation of what we learned last time. Okay, the first thing we're going to learn about is point-slope form. Okay, this is a new form for us. This is point-slope form. It looks like y minus y1 is equal to m parentheses x minus x1. This form is really useful to find equations. Okay, when they say find an equation, you're probably going to try to use point-slope form first. Okay. The downside to it is you usually need to rewrite it in a different form, like slope-intercept form, because if we don't leave it in slope-intercept form, we start at slope-intercept form and then we solve for something else. Okay. All right. Do we have this down? All right. All right, so here we're going to use point-slope form. Right? It says we want to write an equation. It says the line passes through -5, 2 with slope of 3/5. What is the equation of the line? We're looking at point-slope form. Do I have a point on the line? Yeah, I have a point which is -5, 2. Do I have the slope, which is 3/5? All right. Now we're going to use point-slope form, which is y minus y1 is equal to m parentheses x minus x1. y1 and x1 just means that point 1. Okay, so that's just the name of the point. So those you get from there. The x and the y that are by themselves, like here and here, those two are just your variables, right? Because your end answer is going to be like y equals, something x plus something, right? So those two are the ones that are going to stay as x and y. The y1 and the x1 you get from there.
What about the m?
The m is your slope, right? M always stands for slope, which we get from over here. So now we plug it in, so we get y minus y1, which is 2, equals my slope, x minus x1, which is at -5.
Wouldn't it just be +5?
It would become a +5, right? Two negative signs make a plus sign. Now, what did I say about leaving it in this form?
You need to rewrite it?
Yeah, usually you need to rewrite it. Sometimes the equation will just say, or sometimes the problem will just say, write it in point-slope form. But like most of the time when you're solving word problems or anything else, you're actually going to be putting this into some other form. How can I take this and change it to slope-intercept form?
Distribute.
So I could both of those together, right? Distribute and add 2. All right? So I'm going to distribute there. That gives me 3/5 x plus 3. 3/5 times 5. Yep. And you can always do those on your calculator too, right? Yeah.
So when you do like 3/5 times 5, that equals 3. So say you did like 6/9 minus 6, or not 6, but 9, and that's 6.
Yeah, exactly. So what I did here with this fraction times 5. 5 is really a fraction of 5 over 1. The 5s are top and bottom, so they cross off, leaving me with 3 over 1, which we know is just 3. All right? So I just cross-reduced it. It made it a lot easier. Then we're going to do whatever the other person said, which is add 2 add 2, y is 3/5 x plus 5. Right. That's the answer, right? That's an equation in slope-intercept form of the line. What was the slope of the line, of this line? And what point does it go through? Negative 5, 2, good. All right, any questions? Okay. Okay, on this one, it says the line passes through point 32 and point 58. What is an equation for this in, this one they said in point slope form, right? So do we need to solve this one?
Yes.
No, because if they said point slope form, which is one we get, not slope intercept. All right, but point slope, do I have a point? Yeah, I have how many? 2. I got more than one. Do I have slope? I'm going to tell only slope. Does that mean I can't do this? Y2. So I know that slope is equal to y2 minus y1 over x2 minus x1. Right? When you have 2 points, you can find slope. So when I plug those in, I get, which one do you guys want to be point 1 and point 2? Would it give you a different answer if you switch those 2 around? No. Same answer, okay? Just different ordering of things, right? So y2 is 8 minus y1 is 2. x2 is 5 minus 3. 6 over 2, which is? Yep. So that's my slope, right? Now can I use point slope form? Yeah, that's right. You can just get to pick one of them, right? Does it matter which one you pick? No, right? Now, although it does, in the equation, it does say x1, y1, which would mean that we're using this point 1, right? If you use the other point, they mean the same line. And in fact, if you solve for slope-intercept form, you're going to get the same exact answer anyways. But we can use whichever line we want. Usually what I do is I try to pick the one I think the math is going to be easier with, right? But in this case, we don't have to solve. But which one of those 2 points do you think has easier math? The 3, 2, right? It's just, I mean, smaller numbers are usually easier to do math with. So I'm going to have y minus which number? 2 equals my slope, which is 3, x minus my x, which is what? 3. Do I have to go further? No. They said point slope form, that's point slope form. Okay? Be careful when you're reading the problems and you put it in the right form that they want. All right? If they say point slope, it should look like this. If they say slope intercept form. Yeah.
So for this one, y minus 2 equals 3, x minus 3, that means this solution.
Yep, because of point slope form, this is point slope form, right? Now, did anybody here want to use point 2 instead of point 1? Yeah, sure, why not? Okay, so this case, I'm going to say that I want to use this point instead. So here it's going to be y minus y, which is 8, equals 3 parentheses x minus my x, which is 5. Do those 2 equations look different? Yes, they look different. Are they different, though, mathematically? No, they mean the same thing. Okay? So these types of problems, if they have 2 points, we'll have 2 correct answers. All right? Okay, next we're going to learn about another form. Okay, this one's called standard form, where it has ax plus by equals c, where a, b, and c are real numbers. Okay, so it means you can't put any imaginary numbers in there. Now the perks to standard form are that it's a lot easier to do when linear programming, solving linear equations. Computers run with these a lot faster than the other forms, and it's okay to graph. Not as easy as slope-intercept, but it's okay to graph. The downside is it doesn't tell you slope, doesn't tell you y-intercept, right? So there's some upsides and downsides to this one. All right, does everybody have that down? Okay, here, that's what we're going to do. So here we have an equation of a line y equals 3/4 x minus 5. What form is it in right now? Slope-intercept form. What form do we want to get it in? There we go. So what we have right now is that. What I want to get this in is where we have x and y's together, right? And then the numbers on the other side. All right? So can I minus 3/4 x to get to the other side? Yeah. So that's going to give me negative 3/4 x plus y is equal to a negative 5. Is that standard form? Yes? The question mark at the end? Yeah. All right, this is standard form. Is this what they wanted, though? No. They wanted us to use standard form with integer coefficients. What's an integer? It's a number. What type of number? Positives? Non-fractions. There's one other part, not just positives, but they're also negatives, right? So it's positive or negative whole numbers, right? No fractions. Do I have any fractions in there? How can I get rid of the fraction? Still not good. It wouldn't be a fraction anymore, but we want it to be a positive or negative whole number. So making a decimal won't make that a whole number. How do we get rid of a fraction? Times it by what? Close, but not quite there. All right? So we are going to times it by something. That something is going to be the reciprocal of just the bottom, right? So I'm not going to times it by 4 over 3. I'm just going to times it by 4 or 4 over 1. Okay? But do I just times it here and that's it? I have to times it everywhere, right? So the 4's cross off, leaving me with negative 3x plus 4 times y is 4y is equal to negative 20. Is that in standard form? Yes. Does it have integer coefficients? Yes. Yeah. They're all positive and negative whole numbers, right? Yes. All right, we're done. That's it. Okay? Now, let me ask you guys something. I'll write this one in red. What I wrote down in red, is that the same or is that different from what we got in blue? They have opposites and everything, but mathematically, is it the same or different? It's the same. So if you got what we wrote in blue and the book has what I wrote in red, would you be wrong or right? You'd be right. You'd be right. You just need to know that there's more than one form that you can see it in, okay? Okay, there's some notes on page 83 about the different types of equations for lines. If you're confused about the different types and everything like that, you might want to copy down, like they have a little chart thing on page 83 in your notes. Okay, that might be something you want to do for test and quiz purposes. All right, now, 83? 83. Page 83. All right, now, right here we have, what type of an equation? Standard form, right? X and Y are on the same side, so it's standard. Now, I told you guys that graphing standard form was okay, not as easy as slope-intercept, right? Slope-intercept's pretty easy, right? You find the intercept, you do the slope, you're done. With here, you have to find the intercepts, okay? Remember what intercept means? Where it crosses the axis, right? And basically what we're going to do here is something called point-by-point graphing, okay? How many points do you need to graph a line? 2. So what I'm going to do is I'm going to use 2 points. You can use any 2 points you want, but remember earlier I said usually it's nice to pick the one that has the least amount of math? Which number is the easiest to do math with? Wrong. 0, right? 0 is so easy to do math with. 1's pretty easy too. They're like close, almost a tie. So what I'm going to do is I'm going to do 2 points. One has a 0 for x, one has a 0 for y. If I plug in 0 for x for this top one, I'm going to get 3 times 0 plus 5 times y is equal to 15. So 3 times 0 is 0, 0 plus 5y is just 5y. I get 5y is equal to 15. What's y have to be? 3, right? Pretty easy to see that one. This one here, we're going to do it the other way. So we have 3 times x plus 5 times 0 is equal to 15. What is x going to have to be there? 5, right? Now I have 2 points, don't I? Can I graph? So I have 0, 3. Which intercept is that one?
X, Y.
Y, because it's on the y-axis. And then we have 5, 0, which is right there, which is the what intercept? X. 2 points. I just need to draw a line through them. I have my line. Is that as easy as slope-intercept form? It's not bad, but it's not as easy, right? You do have to do a little bit of math, right? So it's not bad, but it's not as nice. Okay? Oh, so this one, okay. They have a nice picture of crickets and everything, but did you guys know that you can tell the temperature by how fast a cricket chirps? You guys knew that? So as it gets warmer, a cricket will chirp faster, right? And it makes a linear equation. What? I don't think they chirp very much. So there's probably a limit to how cold it can get. All right, so I forgot to write down the thing, but here we have, if it's 40 degrees in Fahrenheit, they will have 0 chirps. If it's 93 degrees Fahrenheit, they will have 8 chirps per 2 seconds. Okay? So if you count how many they do per 2 seconds. So as it gets warmer, they chirp more often. All right? So first off, we want to graph this. All right, so let me get my graph paper down here. Do I have, how many points do I need to graph a line? 2. Do I have 2 points yet? Kinda. We can make 2 points, right? Does anybody want to try making a point?
40 and 0, 93, 93, yeah.
What was it, 8? There we go. So 40 and 0, 93, and 8. All right? And actually, I think I'm going to change, because my graph paper is not big enough right now, is it? So let's get rid of that graph paper. We'll come up with our own. Yeah, x needs to go up to like 100. But maybe we'll move the, there we go, to 10. And then the y, I could say probably 10. Okay. There we go. I think that one's going to work out just a little bit better. All right. So now we need to put a point at 40, 0. That's 40, 0. And then at 93 and 8, which is right there, right? Connect them as best you can. And we have a graph, right?
Correct.
Good. Part A is done. Part B, we want an equation in standard form. Ooh. How can we find an equation here? What form do you want to use to find equations?
Point slope?
Point slope. Point slope is our go-to form to find an equation. Okay? So let me move those somewhere. Up there, that looks nice. Okay, so do I have a point?
Yes.
I have 2. Do I have a slope?
Yes. No. No.
But I can find one, right?
Yes.
So I'm going to go y minus y over x minus x. So it's going to get us 8 over 53. All right. Ooh, that doesn't look very pretty, does it? Now, I'm going to tell you guys that most of the time you want to leave the slope as a fraction because it's easier to do right around with a fraction. Right? Some cases, though, like this one, when you have a fraction that's so ugly and stuff, it might be better to put it in as a decimal point. Okay? So what's 8 over 53 as a decimal? Does anybody have a calculator out right now?
53 what?
8 over 53.
0.150.
Okay. I'll just use 1, 5. All right? Oh, pretty close. Really good. All right. What this means is for, since chirps are my rise and degrees are my run, right, says for every 0.15 chirps per 2 seconds, the temperature goes up 1 degree. All right. So that's my slope. Now I need to do point slope form. Which point are we going to use?
93 and 8.
93 and 8. Does anybody disagree with him? Everybody wants to do 93 and 8.
40 and 0.
What? What did I say about choosing your points? Yeah, choose the one that looks like it's going to be easier to do math with. Okay? I think 40 and 0 is easier. Would you be wrong to select 93 and 8? No. You do more work probably. So y minus y, that's a 0, equals 0.15 times x minus 40. Well, that's 0, so I get y is equal to 0.15x minus 0.6.
6.
Now I have an equation, right?
No, it's just 6, not 0.6.
It's just 6? Dang it. Thanks for taking away my moment there.
Sorry.
All right. So we get this. Is that what they wanted? They wanted an equation, right? But it has to be in standard form. Is this in standard form? No, we need to.
Want to just add 6?
Do we want what with y for standard form?
X and Y.
Yeah, we want x and y on the same side. So we need to minus, we get negative 0.15x plus y is equal to negative 6. Is that standard form? Yeah, do they say anything about wanting integers or anything like that in this problem? No, so we're okay. Last thing it says is the temperature is 70 degrees Fahrenheit. How many times would a cricket be expected to chirp in 1 minute?
4 times.
Now we can do this a couple different ways. How do you get 4 so quick?
Because I went to the graph.
We can look at the graph and we can say 70 and go hit the graph and go over and we get 4, right? That's one way. What's another way we could do it? Is 70 an x or an a y? 70 is an x. So could I plug in negative 0.15 times 70 plus y is equal to negative 6 and solve for y?
Yeah.
What would you guys expect you'd get if you did that?
4.
I think you'd get 4 too. Okay? All right, so that's it. Oh, you know it's not. How much more do we have? We have a lot more. Jeez. All right, talking about parallel lines and perpendicular lines. Parallel lines, remember, are two lines that go in the same direction but never touch. In this case, we know parallel lines have equal slopes. Okay? If my slope of line 1 is 3, what's the slope of line 2? 3. Easy. Right? If they're parallel, they have the same slope. All right? Perpendicular lines are slopes. Slopes are opposite reciprocals. Okay? So let's look at slope 1, or line 1 again with slope of 3. Close. We have a negative. There's going to be a 3 in it, but we need to do the reciprocal part, right? So instead of 3, it's going to be 1/3. Okay, does everybody see how I got from a positive 3 to a negative 1/3? All right. So, opposite part means that 1 has to be positive, 1 has to be negative, right? Reciprocal. All right. So we take that 3, which is really 3 over 1, and we flip it over to make it a 1 over 3. Right. What? No. All right, so let's try like slope of line A. We'll say this is a negative 3/4. Slope of line B would be what?
4/3.
4/3. Always one is positive and the other is negative. Yeah, exactly. There has to be one of each, no matter what the order is. All right, so here I have two lines, and they want me to come up with an equation. If I'm coming up with an equation, what form am I going to be using? No? Point slope. You always use point slope form when you want to find the equation, right? That's the easiest to solve for. So I need a point. Do I have a point for part A?
Yes.
Yeah, it's 1, negative 3. Do I have a slope?
Yes, you do.
How'd you know it was 6 over 1?
Because when the number up there is next to x, then it's normally the slope.
So you're looking at that slope right there, right?
Yeah.
So this is like line 1, and we're wondering, I don't know what I'm writing, we're wondering what line 2 is, right?
Right.
Since they're parallel, they have the same slope, right? If line 1 has slope of 6, line 2 has slope of 6, right? So I know line 2 has slope of 6. Now, here's the important part. After I get slope from this line 1, do I need any of the numbers from there anymore? Once I get the slope, I'm done with it, okay? Problems will come up, and some people will try to use some other part of that equation. All you're going to be using is slope. Now I have a point, I have slope, I'm ready to go. Yeah. You can leave. You can leave. Leave. You can sit out in the hall. Okay. Now we're going to be using point slope form, right? Which is y minus y1 x minus x1. What's my y1? Negative 3, which makes a plus sign. What's my m? 6. X. What's my x1? 1 minus 1. Does it tell me which form they want it in? Yeah, they want it in slope-intercept form, so I'm not done yet, am I? All right. So I need to distribute.
What's that equation called again?
This one right here? Point slope. Y plus 3 is equal to 6x minus 6, right? Using the distributive property. Then I need to minus 3, and I'm running out of room to show all my steps, but you get y equals 6x minus 9.
Now you're done.
Now I'm done, right? Because I have it in slope-intercept form.
Yes.
Fun, right? All right. This one here is perpendicular. All right. I'll scroll up a little bit. There we go. Perpendicular, right? I want to use point slope form again. All right. Do I have a point?
Yes.
Sure do. Do I have a slope? What's my slope? 1 over 4. Is it positive or negative? Positive, right? Because you need to have one that's negative, one that's positive. My point is 8, 5. Use point slope form. Y minus what's my y? Equals my slope, which is 1/4 x minus my x. Again, we need to put it in slope-intercept. 1/4 x minus dose. And then the last step is add 5. Add 5. Y is 1/4 x plus 3. All right? So those are...
The line perpendicular and the first line is the same exact process.
Same exact process. The only difference is, oh, here it is. How do I get this slope and this slope, right? Because of this, the top one, we took the same exact number, right? Because they're parallel. The bottom one here, we took that number and we made it an opposite reciprocal. So that's the only difference between parallel and perpendicular. All right? Am I ever going to use this plus 2/3 or minus 2? No, all I care about is the slope when I'm doing parallel and perpendicular. All right, good. Here's our assignment for today.